check to see if the following points lie on lines L and M, or neither or both, right? Which ones do they lie on? And to be on a certain line means that you have to satisfy the equation that is that the line represents. So when we look at 2 comma 3, let's put this into L and see if it works inside of that equation. So what would the L equation say? Negative 3 times x, which is the value of 2, plus the y value, which is 3, equals 2. Negative 3 times negative 2 is negative 6 plus 3 equals 2. And so negative 3 equals 2. And that, of course, is a false statement, so this one does not lie on L. But let's try M. M would be x, which would be 2, plus 2 times y, which is 3, which hopefully will be equal to 1. 2 plus 6 equals to 1. 8 equals to 1. No, that one doesn't work either. So the point 2 comma 3 is on neither of the lines. Okay, let's try 1 comma 5. In line L, negative 3 multiplied by 1 plus 5 equals to 2 would be saying negative 3 plus 5 equals to 2, which says 2 equals 2. So 1, 5 does lie on line L. How about M? Well, M would be the x value, 1, plus 2 times the y value of 5. 1 plus 2 times 5 is 11, but that's not equal to 1. So we fail being on M. So the point 1 comma 5 is only on L. Okay, how about the point 3 comma 11 then? Well, for line L, what would we have? We'd have negative 3 times 3 plus 11 equals to 2. Negative 3 times 3 is negative 9 plus 11 equals to 2, and that's a true statement. So that point is on L. For M, we have 3 plus 2 times the number 11, hopefully equals 1. 3 plus 22 equals 1. No, that one's way off. 25 doesn't equal 1. So the red point 3 comma 11 is only on line L. And finally, let's try negative 1 comma 2. For line L, we would be saying negative 3 times negative 1 plus 2 equals to 2. 3 plus 2 equals 2. 5 equals 2, and that's a no, so this time it's not on L. And for M, we would be saying x is negative 1 plus 2 times 2. 2 times 2 would be equal to 1. Negative 1 plus 4 would be equal to 1. So 3 equals 1, so that one's not true either. So the first point and the last point were on neither. The second point and the third point were on L but not on M. And that's the final answer for this set. Okay, so why don't you try a set on your own? Come over here and take these two lines and see if you can evaluate them in the same way as I did the previous problem. So assuming you gave it a good shot here, let's do it together. For line L, we would have y equals 2 times negative 2 plus 4. In other words, 1 equals negative 4 plus 4, 1 equals 0. That's a false statement, so that one's not the case. That one's not on the line. Negative 2, 1 is not on L. And for M, we would have 1 equals 5 times negative 2 minus 5, which would be 1 equals negative 10 minus 5, or 1 equals negative 15, and that's not true either. So that point does not lie on either of the lines. How about for 310? Does 10 equal 2 times 3 plus 4? In other words, does 10 equal 6 plus 4? Yes, 10 does equal 10. So this one works for L. How about for M? Does 10 equal 5 times 3 minus 5, in other words, does 10 equal 15 minus 5? Hey, that one's true too. So that's our first instance of a point that's actually the intersection of the two lines and satisfies both of the equations simultaneously. Okay, how about 1, 0? For 1, 0, we would be saying 0 equals 2 times 1 plus 4. In other words, 0 equals 6. So no good for L. And in M, we would be saying that 0 is equal to 5 times 1 minus 5. In other words, 0 equals 5 minus 5. And that one's actually true. So here's an instance where it is true for M, but not true for L. And final example, let's do 2, 8. And let's see, so in line L, we would be interpreting this as L, or the y value of 8, is equal to 2 times 2 plus 4. 8 equals 4 plus 4. 8 equals 8. That's a true statement for L. For M, we would be getting the statement 8 equals 5 times 2 minus 5. 8 equals 10 minus 5. 8 equals 3. And so that one is not a true statement.